In this video, I am going to be showing you how to find the LCM, the least common multiple, by using a different method. So what is the LCM? The LCM of two or more numbers is the smallest number that is evenly divisible, so no decimals are going to be allowed, by all numbers in the set. All right, let's look at example 1. Let's find the LCM of 12 and 40. The first step in my method for finding the LCM is to find the prime factorization for each of the numbers listed. I already did this for you, and so if you want to learn more about prime factorizations, you can check out the video I made for prime factorizations. I've circled the prime numbers in red for each of the numbers. These numbers are going to be crucial for our method. And so the next step is that I'm going to be creating a table with rows and columns to list out my prime numbers. So I'm going to do that now, and I'm going to put 12 on my top row and 40 on my bottom row. And the order of this doesn't matter. The next step is, since I placed 12 on my first row, I'm going to list each of the prime numbers for 12 by separating them into columns. And the order you list the prime numbers, that doesn't matter either. So my prime numbers for 12 are 2, 2, and 3. And so the next step is that I'm going to look at the prime numbers for 40. If you have a prime number in the top row that is in common with a prime number of 40, you will place that number below it in the column. If the prime number isn't already represented in the row above, you will create a new column for that prime number. So I'm going to do that now. And so as you can see, I have the 2's that are already represented in the top row, so that's why I put them below it. And then I'm creating a new column for 2 and a new column for 5. And now I've listed all of my prime numbers for 40. After all the prime numbers are listed in my rows and columns, you're going to cross out the repeats. And so the repeats are all the numbers below another prime number in a column. So here I'm going to cross out both of my 2's since they are already represented in the top row. And then now all that I have left, there's no other numbers and no other prime numbers with anything below them. And so the numbers remaining are going to be giving us the LCM. And so I've highlighted them in yellow. And so to find the least common multiple, or the LCM, you will be multiplying the remaining prime numbers together. So the LCM for 12 and 40 would be 120. Okay, let's look at example 2. Let's find the LCM of 25 and 30. So I'm going to find the prime factorizations for 25 and 30, which I've done that here, and I've circled them, the prime numbers, in red. So then my next step is that I'm going to be creating a table with rows and columns to list out my prime numbers. And so I'm going to be putting 25 in my top row, and I'm going to put 30 on my bottom row. And once again, the order here does not matter. And so now I'm going to list each of the prime numbers for 25 by separating them into columns. So I have a 5 and a 5. Those are the only prime numbers for 25. And then again, the order that you list the prime numbers doesn't matter. And so now I'm going to look at the prime numbers for 30. And if I have a prime number in the top row that is in common with a prime number with the 30, I'm going to place that number below it in the column. If the prime number isn't already represented, I'm going to create a new column for that prime number. And so as you can see, I only have, there's only one 5 as a prime for 30, so I'm going to go ahead and list that below my first 5, and then I have to create 2 different columns for my other remaining prime numbers. And so now I have all of my prime numbers listed for 30, and I have them all listed for 25. So after they are listed in my rows and columns, my next step is I'm going to cross out any of my repeats. And the repeats are the numbers below another prime number in a column. So here I'm only going to be crossing out my first 5 because that's the only one that is below another prime number. And so the prime numbers remaining will give us the least common multiple, and I've highlighted them in yellow. So to find the LCM, you'll multiply the remaining prime numbers together. So the LCM for 25 and 30 is going to be 150. Okay, let's look at example 3. Let's find the LCM of 15, 24, and 18. The process is going to be the same even if you have more than two numbers. And so you're still going to find the prime factorization for each of the numbers listed. And so I already did this for 15, 24, and 18. And I've circled the prime numbers in red for each of the numbers. And once again, these are the crucial numbers for my method to find the LCM. And the next step is that I'm going to be creating a table with rows and columns to list out my prime numbers. And so I'm going to put 15 in my top row, 24 in my middle row, and 18 in my bottom row. And the order here does not matter. And so since I placed 15 on my top row, I'm going to list out each of the prime numbers for 15 by separating them into columns. So the prime numbers for 15 are 3 and 5. Okay, and the order you list the prime numbers doesn't matter here either. Now I'm going to move on to 24. And so I'm going to look at the prime numbers for 24. If you have a prime number that's in the top row that is in common with a prime number of 24, I'm going to place that number below it in the column. If the prime number isn't already represented, I'm going to create a new column for that prime number. And so, as you can see, I do have a 3 for a prime number of 24, so I'm going to put it below my first 3. But then I have to create new columns for my other remaining prime numbers for 24. And so I'm going to do that now. And so now I've listed all of my prime numbers for 24. Okay, so now I'm going to look at 18, and I'm going to look at the prime numbers for 18, and same thing, if you have a prime number that is in the top row or in even in the middle row now that is in common with the prime number of 18, I will place that number below it in the column. If the prime number isn't already represented, I will create a new column for that prime number. So looking at the prime numbers for 18, I do have a 3, so I'm going to go ahead and put it below my top row 3. And then I have a 2 represented, and so I'm going to put it below my 2 that's in my second row. And then now I have to create another column for my final 3, which is the last prime number for 18, since I don't have it represented in any of my above rows. After all the numbers are listed in my rows and columns, I'm going to be crossing out the repeats, and then the repeats are the numbers below another prime number in a column. So here I'm going to be crossing out my 2 3s for the 24 and the 18, and then I'm also going to be crossing out my 2, that's the prime number for 18. And the prime numbers remaining will give us the LCM, and so I've highlighted them in yellow. And so to find the LCM, you're going to be multiplying the remaining prime numbers together. And so the LCM for 15, 24, and 18 is going to be 360. So let's look at example 4, a word problem. 3 coworkers are busy selling insurance policies over the phone. In an 8-hour day, KJ can sell 6 insurance policies. Nico can sell 8 insurance policies, and Eve can sell 16 insurance policies. We want to find the LCM of the number of insurance policies that each worker can sell in an 8-hour day. So remember, our first step in this process is to find the prime factorizations for each of the numbers, which I have done here for you. And I've circled the prime numbers in red for each of the numbers. And these numbers are critical in our method to find the LCM. The next step is that I'm going to be creating a table with rows and columns to list out my prime numbers. And so I'm going to have 3 rows. I'm listing 6 in my first row, 8 in my middle row, and 16 in my last row. And I'm going to be putting the prime numbers for 6. Since I've listed that in the top row, I'm going to be placing the prime numbers in the top row, and I'm going to be separating them into columns. So the prime numbers for 6 are 2 and 3. and the order that I'm listing these numbers, that does not matter. Next, I'm going to look at the prime numbers for 8. If I have a prime number in the top row that is in common with the prime numbers of 8, I'm going to place that number below it in the column. If the number isn't already represented, I'm going to create a new column for that prime number. So looking at 8, I do have 2 already represented, and so I'm going to place it below my first 2, and then I do have to create new columns for my other prime numbers for 8. And now I have all my prime numbers represented for 8. I'm going to do the same thing for 16. I'm going to look at the prime numbers for 16. If I have a prime number in either the top row or the middle row that is in common with a prime number of 16, I'm going to be placing that number below it in the column. And if the prime number isn't already represented, I'm going to create a new column for that prime number. And so since I have 2 already represented in my first column, I'm going to place it there, and I actually am able to place my other 2s below my 2s that were in my row for the primes of 8, but then I still have one more 2 left, and so I have to create another column for that final 2. And so now I have all my primes listed here for 6, 8, and 16. So after all the prime numbers are listed in my rows and columns, I'm going to cross out the repeats. The repeats are all the numbers below another prime number in a column. So here I'm going to cross out the 2s below my first column 2, and then I'm also going to be crossing out my 2s here that are below the prime numbers that were above it in the row for the 8. And then the remaining numbers, which I've highlighted them in yellow, those prime numbers are going to be giving us our LCM. So to find the LCM, I'm going to multiply the remaining prime numbers together. And so the LCM for 6, 8, and 16 is going to be 48. And so step 2 of my word problem says, what is the smallest number of 8-hour days needed for each of them to achieve the same number of cells? So what I would do for each of those workers is I would take the LCM, which is 48, and I'm going to divide it by the number of insurance policies they each sell, and then that will tell us how many days. So for KJ, it will be 8 days, Nico 6 days, and Eve, it will be 3 days.